Hello everyone, welcome to my channel. Today's topic of discussion is about the difference between monoalphabetic and polyalphabetic substitution cipher. I shall explain the difference between a monoalphabetic and polyalphabetic cipher with the help of an example. Let me say I've got a secret word called as noon which I want to transmit to the other end using a public communication channel. Let me say internet. Now since the word noon is a secret, I have to keep it safe from being read by attackers. Therefore, I use an encryption algorithm. I encrypt the word noon into a cipher text using an encryption algorithm. Now let us assume that the encryption algorithm which the sender is using is a monoalphabetic substitution cipher which converts secret message noon to the cipher text GKKG. Now a substitution cipher substitutes N with some other letter, that is G in this case, O with some other letter, that is K in this case. So since N is substituted with G and O is substituted with K, it is known as substitution cipher. While monoalphabetic substitution ciphers are the ciphers which uses one-to-one mapping between the plain text and the cipher text. So every time a letter repeats in the plain text, the corresponding cipher text letter also repeats. Now the repetitive pattern is actually a drawback of the encryption algorithm, because if the attacker gets to know the cipher text and he knows that you are using a monoalphabetic substitution cipher, say from this example, the attacker quickly knows that the sender is using a 4-letter word and which is made up of 2 letters. So the attacker has reduced his search area to searching only 4-letter words in which first 2 letters are the same and the middle 2 letters are the same, and therefore it becomes very easy for an attacker to guess the plain text from this cipher text. So since monoalphabetic ciphers using one-to-one mapping, if there is a repetitive pattern in the plain text, the repetitive pattern can also be seen in the cipher text, and that repetitive pattern can be easily used by the attacker to predict the plain text from the cipher text, and hence monoalphabetic substitution ciphers are highly vulnerable to security attack. One way of overcoming the security attack is to use a polyalphabetic substitution cipher. Let us say the polyalphabetic substitution cipher has converted the plain text noon to the word GKFM. Now, as seen from this example, the substitution cipher replaces N or substitute N with the letter G. The cipher then substitutes O with the letter K. But when O occurs for the second time, rather than replacing it with K, as you can see here in the cipher text, it has been replaced with F. Again, when N occurs in the plain text, rather than replacing it with G, it has been replaced with M. So you can see that polyalphabetic substitution cipher makes use of one-to-many mapping. That means N will be mapped to G. The second time it occurs, it is mapped to M. The third time it occurs, it may be mapped to some other letter. The fourth time it occurs, it will be mapped to some other letter, and so on and so forth. Similarly for O, O is first mapped to K, but when it repeats itself, it is mapped to F. When it repeats again for the third time, it will be mapped to some other letter, and so on and so forth. So a polyalphabetic substitution cipher basically hides the repetitive pattern occurring in the plain text and hence protects the cipher text from being attacked by attackers. Polyalphabetic substitution ciphers therefore hides the frequency of repetitive characters in the resultant cipher text, and therefore polyalphabetic ciphers are cryptographically stronger as compared to monoalphabetic substitution cipher. Let us see some of the polyalphabetic substitution ciphers. They are Vigenère cipher, AutoKey cipher, and Varnam cipher, which we will be doing in the coming videos. So with this, we come to an end of this video. Thank you guys. Stay happy, stay blessed.